Hi, I'm Don. We have a 1982 Great Lakes 33 trawler, a great boat. Replaced the engine in 2010 with the Volvo D2-75. It's been a great, reliable engine, but we've had a few problems with the electrical system, including the MDI box. Now, the MDI box controls a few things on the engine. But it's not a single rail, so it doesn't control the engine operation itself. It just controls the timing of the glow plugs and all the alarms and so on. But it was giving trouble, and because we often go to places that are remote, we can't get help, I wanted to have something very reliable. So most of this video is dedicated to showing how to replace the MDI box with a mechanical relays and analog instruments and so on. Done that a couple of years ago, and it's worked just great ever since then. However, there's a few other things on the engine that I just like to touch on that cause a problem in the electrical system, so that's what this video is all about. So just to summarize, here's the problems we had. First of all, the house batteries were charging way too fast and getting very hot. The engine would start usually, but sometimes not. Every now and then I would have to jump start it. When the engine was very cold, it would crank a long time before firing. We had a problem with alarms sounding when there was nothing wrong, and the controls that we got with the engine did not include temperature or oil pressure gauges, and I like to see those. So what we did, converted the alternator for an external regulator. A local shop did that for us. And then I put in a Xantrex 3-stage voltage regulator. And then we removed the MDI black box and put in all new wiring with relays and analog gauges and added oil pressure and temperature gauges, and put in some extra interlocks to prevent the engine from starting when it was in gear or when we had not opened the cooling water valve. That was from bitter experience. Here's a picture of just the overall engine wiring, just to put things in perspective. There's the alternator. It charges the house battery bank, which in turn charges through an echo charger, charges the starting battery. It's a very good and robust system, and it protects the batteries well. The engine is set up so that we can use the main battery switch to start the engine either on the starting battery or the house batteries, but we cannot run the house loads off the starting battery. Battery charger charges the house batteries, and then the starting battery through the echo charger. There's a little D2-75. You can see the MDI box on the side of it, and you say, well, it's a bunch of electronics. You mount it on the side of a heat exchanger on an engine that's subject to vibration, and you say, what could go wrong? Well, the answer is several things. If you go online, you'll find all sorts of problems with the MDI box, and I could have replaced it, which was quite expensive, and of course I knew it was unreliable anyway. I didn't want to do that, so we decided to go with the analog solution. Here's the original electrical panel, at least instrument panel, that came with the engine. All it had was the operating buttons, and the alarms just showed up on this little LED screen here, and that's all it was. So there's the MDI box. As you can see, it's mounted right on the heat exchanger, and runs very hot when the engine is running. There's the wires that we removed to start the project, and we replaced them with, I think there was 194 wires that we needed to do the job. And that may sound a lot more complicated than it is. There's actually a whole lot of very simple circuits, and if you do them one at a time, it's not a difficult job to do. Set up the interlocks so that the starter will only operate when the engine is not running, and that's controlled through the oil pressure switch. the engine has to be in neutral and the cooling valve has to be open. So I had to add limit switches for those, and you'll see those in later slides. We've also set it up so the alarm will sound when either the oil pressure is low, the engine temperature is high, and the voltage is either too high or too low, and that's fed from the voltage regulator. And for each of those alarms, there is a panel light comes on as well. There's the wiring diagram for the engine. It looks complicated. I believe it's clear enough that you can screen dump that and print it if you want to see it. But just as an overview, you will see that in the engine compartment here we have the voltage regulator, some of the limit switches, the glow plugs, the stop valve, the starter, and so on. Beside that, there's a little panel that has the relay for the starter and the relay for the glow plugs and the relay for the starter. Underneath the instrument panel, under a new panel, there is most of the wiring is in there. There are 4 relays for controlling the alarms and the interlocks. There are the gauges, oil pressure, temperature, and new tachometer, which also has an hour meter on it, and 3 warning lights. Also down in the engine compartment is the Xantrex voltage regulator, and the alternator, and the wiring for that is part of the whole circuit. This wiring is protected by a 15 amp fuse, protects all this wiring except for the glow plugs, and there's a 50 amp fuse protects the glow plug circuit. There's the new panel. The preheat valves for the glow plugs, that's just manual. I just hold it for a few seconds before you press the start button, a few more if it's really cold. There's a light up here that goes on when all the interlocks are satisfied. If that green light is on, then you can press the start button and the engine will start. The Elgin tach has got an hour meter on it, and there's the temperature and oil pressure gauges. I added a little manifold on the side of the engine, connected into the port that had the Volvo oil pressure switch on it. That runs through a manifold here with a oil pressure sending unit and a new oil pressure switch for controlling the electrical system. And there's the Xantrex voltage regulator, and I set that up so that sitting in the helm seat, I can see the end of it where all the LED lights are, so you can see by glancing down, you can see what stage of charge it's at and so on. This is the base of the panel that's beside the engine now. It has a 50 amp fuse for the glow plugs, a 15 amp fuse for all the other circuits, and so on. And the relays are mounted on this board as well. And this is the back of the new instrument panel before I mounted the board with all the relays on it. It's the back of the gauges and panel lights and push buttons. That's the circuit board beside the engine in the engine compartment with the relays for the starter and glow plugs, the 15 amp fuse, 50 amp fuse, and so on. It's all in there. That's it with a cover on it. I covered all the panels with plexiglass, but I drilled a hole above each terminal so that you can poke a voltmeter through there for troubleshooting. This is the back of the instrument panel. There's a 12 volt bus here. There's the 4 relays there. There's the 3 warning lights and a ground bus as well. And that's the other side of it. You can see there's the instruments and the push buttons as well. The umbilical cord that goes to the engine has got a couple of feet of slack in it, so that it's easy to pull the instrument panel out for doing any servicing or troubleshooting. Beside the engine, this is the wiring that goes up to the instrument panel. These wires go to the engine, But this is set up so that you can just disconnect all these if you ever want to remove the engine. The other thing I've done here is put a couple of leads in here that are connected by a spade connector, and connecting that bypasses the oil pressure switch for troubleshooting or for setting the voltage regulator. That's usually left disconnected. And there's the same panel again with the holes above each of the strips, so that if you want to, you can there's a piece of wire I leave hanging here which is a jumper. If you want to jump to the start relay, just put a jumper through those two holes and you can jump start the engine, should anything go wrong, which it has not to date. I also made up a wiring schedule, so each wire has got a line in here that shows what gauge is, what color it is. I shrank little pieces of shrink tubing on the end to identify them, just where it went from, where to, and what its purpose is. There's a picture of the engine through-hole valve. You can see this little shoe here moves with the valve and operates this limit switch here to make sure that you can't start the engine, as I have tried to do in the past with the valve closed. Same sort of thing. This is the lever for the transmission. There's a limit switch under there, and this little shoe here operates that. That's the end of this video. It's certainly a do-it-yourself project. It takes a little bit of time, but what it results in is a very reliable electrical installation that you can make do what you want. For example, adding extra interlocks, as I did. Much less expensive than replacing the MDI box and perhaps the panel instrument as well. And it uses just standard low-cost components that you can keep on board as spares. It's very easy to troubleshoot, and it's also easy to repair with the things that I have on board, no matter where I am. So that's the end of that. If you want to contact me, you can send me a text at 250-886-6115. Thanks for watching.